Thank you for tuning in and welcome back. In this 6-part video series on bioenergy, I would like to give you an introduction to energy production from biomass. In this 5th episode, Carbon and Bioenergy, following a brief introduction, we will discuss the following points. Point 1. Natural CO2 cycle instead of fossil one-way street. Point 2. Influence of land management on CO2 concentration. Point 3. Replacement of fossil CO2 emissions and negative emissions. As always, a short summary will conclude this episode. Let's start. Carbon is the central building material of life. All plants and animals consist of carbon compounds and therefore also our food. It takes a lot of effort to preserve food. Without refrigeration, the rotting process begins within a few hours and the food spoils within a few days. The same process that happens very quickly with edible food takes weeks, months or years with other biomasses. While autumn leaves usually rot in spring, the stored CO2 in wood can take several years to get back into the atmosphere. The dismantling happens surprisingly quickly here too. A 30 cm thick beech trunk is half rotten in 7 years. By using it, we can stop the decay process and use the stored CO2, for example, as a building material or as a replacement for fossil fuels. Interestingly, the same amount of CO2 is produced during rotting, digestion and combustion anyways. Point 1. Natural CO2 cycle instead of fossil one-way street. In the biomass they produce, plants bind carbon through photosynthesis in their leaves. For 1 kilo of carbon they remove 3.7 kilograms of CO2 from the atmosphere, and with the help of 1.5 liters of water, 2.7 kilo of oxygen and 2.5 kilogram of sugar are created. Around 11 kilowatt hours of solar energy is stored in this. The plant now uses the biomass itself as an energy source and to build plant parts. Oxidation is the opposite process to the photosynthesis, in which the biomass is broken down again with the help of oxygen. CO2 and water are created again and the energy can be used. Digestion, rotting and combustion are oxidation processes that make biomass usable. Since the same amount of CO2 is stored during the plant growth as is being released during oxidation, the digestion, combustion and rotting of biomass is CO2 neutral. The Earth's CO2 cycle is enormous. Every year around 123 billion tons of carbon are removed from the atmosphere by plants and 120 billion tons of carbon are released again through oxidation. Fossil fuels come from the Earth's crust and shift an additional 8 billion tons of carbon from the Earth's crust into the atmosphere every year, which was led to climate change. Point 2. Influence of land management on CO2 concentration. Very large amounts of carbon are stored in the living and dead biomass in forests, grassland and arable land. During forest fires, deforestation or drying out of moors, very large amounts of carbon can be released into the atmosphere. Sustainable management ensures that these carbon stores are kept as high as possible in the forests. This means adapting tree species to climate change and replacing felled trees with new trees. No longer using the forest for climate protection reasons is not an option, as climate change leads to the fact that forest damage and forest fire spread more quickly and neglected forests and thus threaten the entire forest. Well-maintained forests do not only have higher wood stocks, but also have a higher biomass increase than unkempt forests. Point 3. Substitution effects and negative emissions. Europe and Austria have committed to the goal of achieving climate neutrality, followed by removing CO2 from the atmosphere again. Climate neutrality is achieved when the greenhouse gas emissions caused by humans are equal to the greenhouse gas emissions removed from the atmosphere. Bioenergy can be helpful in reaching these goals, mainly for 3 reasons, and is therefore, from the perspective of the International Energy Agency and the Intergovernmental Panel on Climate Change, essential for achieving energy and climate goals. Point 1. Biomass replaces fossil fuels and, together with other renewable energies, enables the complete phase-out of the burning of coal, oil and natural gas. Point 2. Bioenergy use is an essential part of sustainable management and helps to keep carbon stocks and biomass growth as high as possible. Carbon can be separated from the flue gases of large bioenergy plants and relocated into the Earth's crust, creating negative emissions that can be used to cool the climate again. Let's summarize this episode. Bioenergy uses the natural CO2 cycle of photosynthesis and oxidation, digestion, rotting and combustion. The natural carbon cycle is vast. If only 5% of this carbon cycle can be used to generate energy, together with the other renewable energies such as wind, water, solar, ambient heat and energy efficiency, this amount would be enough to completely phase out natural gas, oil and coal. Bioenergy offers the unique opportunity to cool the climate with negative emission by capturing carbon from large systems and injecting it into the Earth's crust. The question how much bioenergy we need for the energy transition was discussed in the previous episode. The next episode deals with criticism of bioenergy and discusses its justification. We are looking forward to reviews and invite you to leave us a comment. Or forward us some questions or comments to office@biomasseverband.at. Thank you for watching.